Hola, SAP developers. Welcome to this session part of the DevFest 2023 integration track. Before we start, I just want to let you know to please feel free to drop us your questions in the chat window as we'll be monitoring it during the session. Now, while building integrations with different systems, it is likely that you've had to deal with lots and lots of XML messages. Today, we have Morten, who is a well-known community member and an SAP mentor. He will introduce us to XML standards that every SAP Cloud Integration developer should be familiar with. Without any further delay, hola, Morten, over to you.
Thanks, Antonio. Thanks for inviting me. I appreciate it. And welcome to the session. I hope you've had a great DevFest so far, all of you. We've got a lot of ground to cover in the next 30 or 40 minutes or so I'll just introduce myself very briefly. My name is Morten Wittrock. I'm based in Heidelberg, Germany, and I have a sort of German-sounding last name, but I'm actually Danish. I work at Deloitte Consulting in the SAP offering. I'm actually sat in the office here in Waldorf right now. I'm also part of the SAP Mentors program and just generally loves contributing to the SAP community. Let's keep it at that for now. Yeah, like Antonio mentioned, I'm going to talk about XML standards that I feel that every SAP Cloud Integration developer should know. I'm going to cover 4 standards. But before getting into those, let's start by doing a brief introduction to XML and also establishing some shared terminology that we're going to use later. So first off, what is XML? It's Extensible Markup Language, which raises another question: what is a markup language? And markup is a way to inject some structure and meaning into a text document. There are quite a few markup languages out there. I think most of us know at least one, HTML, hypertext markup language, probably the most well-known one. And HTML defines a bunch of tags you can insert into a page to mark up images, links, and so on. All the stuff that makes up a web page. And when you view that page in your browser, that's the result of the browser processing that markup and the content to produce something you can see on the screen. But XML is different in a crucial way because XML defines a fixed set of tags you can use. But XML lets you define your own tags. And actually, you have to define your own tags because XML doesn't have any predefined tags. So that's the key takeaway here. XML doesn't define any tags. You do, right? So XML is more like a meta language for creating markup languages. That's the extensible part of the name. Defining those tags and their semantics, the meaning of the tags, sometimes known as creating an XML vocabulary. And yeah, you can define your own, or you can use a very large number of existing industry standards covering all sorts of business objects and also business documents. Let's look at an example. This is the content of this presentation with some markup that I added. So the content is the title, the presenter, when does the presentation take place, and so on. And the markup gives some structure to this content, right? So this could be processed by, I don't know, some software that shows the next session on a screen at a conference, right? This could process this XML and then display the content on a monitor somewhere. Okay, so you might be asking yourself, isn't XML just really dinosaur technology for old people? And well, technically, XML is really old. It dates back to sort of the mid-90s. And, to point out the obvious, older doesn't necessarily mean worse, and newer doesn't necessarily mean better. And to give a bit of perspective to the time, a lot of the technology we're using that we're still considering absolutely very relevant is quite older than you probably think. Python, likely the hardest data science language, goes back to 1991. Also, the HTTP protocol that we are using constantly, R, another data science language, 93. Both Java, JavaScript, 95. So a lot of this technology is dates back to the previous millennium, basically, right? And especially in enterprise integration, XML is indeed alive and very well. And why is that the case? Yeah, let's look at some of the advantages and disadvantages of XML. Advantages: very broad support across different platforms, different programming languages. Really good tools available for working with XML, and some really high quality libraries for all sorts of programming languages. Some of the standards are quite old and they don't change that often, but the other side of that coin is that they are very mature and they're very stable as well. And as I mentioned briefly before, there is a ton of existing very high quality vocabularies for all sorts of business documents. So if you need to exchange business documents with partner systems, it's very likely that you don't need to come up with your own XML vocabulary. You can use an existing one that's already been defined for you. What are some of the disadvantages? The number one that gets mentioned the most is likely that XML is very verbose. And that is true. Like you saw on the example document, all the content has a start tag and an end tag. And that means that if you have something like a list-like structure or an array in XML, then every single item will have a start tag and an end tag. If you want to make those tags more human-friendly, they will be longer, so they will be repeated a number of times for every item. So that does balloon the size of an XML document. Also, complexity. Not so much of the XML standard itself. That's not that complicated actually, but more like some of the surrounding standards. And the worst offender is probably the web services standards, collectively known as WS star, sometimes more cheekily known as WS Death Star, because those are in some cases just ridiculously complicated. The last one, the last bullet, not human readable. That's a common criticism, but actually one that I don't really agree with. I think XML can be quite readable. I think the example document we saw with the presentation is fairly readable, especially with indentation to highlight the structure and so on. But nevertheless, it's a criticism that serves us quite a bit. Let's go into a bit more technical stuff before we go to the standards. Let me highlight some of the anatomy of an XML document, and also to establish a bit of terminology. The bit up here is the XML prologue or the declaration. with a bit of meta information about the document, like the encoding. It's not mandatory, but it's a good idea to include in your document. Got a root element here, presentation in this case. This is a tag, a start tag, and a corresponding end tag with a slash in front. The content is what's in between the tags here. And the whole thing, start tag, content, the end tag is known as an element. And we also have a special syntax here for empty elements. So elements without any content or any child elements. And last up, we got an attribute up here. And yeah, with that terminology in place, we can talk about the concept of well-formed XML. Basically, every XML document must be well-formed. And that means that it follows the syntax rules of XML. And that probably sounds a bit more complicated than it actually is, because the rules are really quite straightforward. I'll show some of them afterwards, but basically it boils down to this: there can only be one root element. Every start tag must have an end tag. The elements must be properly nested. All the content you have in your document must occur between tags. Attribute values must be quoted with double quotes. Tag names are case sensitive, unlike HTML, for instance. And there are some element naming rules to be followed, like an element name must start with a letter or an underscore. But after you've been using XML for quite a short while, all these rules become second nature, and any document that doesn't follow them will just immediately occur very odd to you. And also, in addition, every parser you work with, or IDE tools like Pretty Printers, they will check the well-formedness for you if you don't do it. So just a few examples here. One root element only, so this works, but having two is a no-go, and your parser will fail on this document. End tags, the message element here has a start tag and an end tag. This is okay. Not okay is not having this end tag. HTML, for instance, allows tags that with no end tag, but this is not HTML. Your XML parser will demand that an end tag is in place. Okay, so this was the part about nested elements, and it's fairly intuitive. I think that you must close elements in the opposite order of opening them. So in this case, we've got a parent element opened, a child element, and the child element is the first to be closed, and then the parent element. So this is what doesn't work, that the parent element is closed before the child element. So this will also cause your parser or your XML tool to grind to a halt with an error. Okay, we've got the fundamentals in place. So let's start with the 4 XML standards. And the first one is namespaces. The standard itself is fairly simple. It's quite short. It's definitely the shortest one of these 4, but the concept can cause some confusion still. So picture this: you've got a purchase order XML document that has 2 different name elements in it, and one is for the company name of the buyer, and the other one is for product names. So
Apologies. I just realized that I was on mute, and I see that yeah, Morten seems like he lost his connection. So we're going to wait for him for a bit now, and let's see. Yeah, when he rejoins, then he can keep on going with the live stream. Apologies about that. He was just getting into the meaty stuff and the good stuff about the XML standards. Yeah. So let's see. Yeah, I just realized that. Thank you very much, Luis, and thank you very much, Shriyansh, for letting me know that I was on mute. Apologies. I have a physical mute button on my microphone, and I forgot to actually click it. Hence why I was on mute. But yeah, we're just waiting for Morten for a bit, and let's see. Yeah. Tammy, I see your question regarding supporting other formats apart from, give me a second. Wait, I have this. Yeah, supporting other formats apart from Morten, there he is. So he's just joining. Give me a second, I'll let him in again, admit. And yeah, so he can resume with his presentation. Morten, welcome back.
Thank you.
Yeah, we lost you there for a bit, but that's okay. It's good that you're back. So if you can share your screen again, and then
Yes.
you can keep going from where you stopped. Yeah, so we see your web browser right now. We see presentation mode of the slides. So you will need to switch screens, I think, or something like that. Yep. You're not sharing yet, right?
Yes, it should be coming up now.
Yep. Okay.
Really sorry about this. My computer crashed.
It's fine. I'm actually surprised that your computer came back so fast. So that's good. Okay, we see your slides. So yeah, you can keep going. Thank you.
Okay, yeah, thank you, Antonio, and sorry again. I think this is where we got to, about the need for XML namespaces. We had two different name elements, and we need to tell them apart. And basically, we can't really. And that kind of name clash can occur, especially when you're combining different vocabularies, which you do fairly often, especially in those industry standard XML types. And this is the problem that is solved by XML namespaces. And it does so by introducing so-called expanded names. And an expanded name is just a regular name combined with a namespace name. And the namespace name is an international resource identifier, an IRI, which is, I guess most of you know, uniform resource identifiers. And this is the same, just with internationalization. So you can use non-ASCII characters, right? So we add a namespace name to those two elements like this. And typically those namespace names are URLs, but they don't have to be. And when they are, the URL doesn't need to actually point to anything that exists. So keep in mind that namespace name is just that, a name, right? It's nothing more than that. So how do we make it operational? Because they are fairly long and cumbersome, those IRIs. So what we do is we abbreviate them using namespace prefixes. And this is what you actually see in XML documents. So you bind a namespace name to a prefix. Using this syntax here, a special kind of attribute. And at this point, we can use the B prefix to point to this namespace. So now we've got the buyer and the name elements inside that namespace. And also, please, this is also a key takeaway, that the prefix itself is pretty much arbitrary. It doesn't matter what it is. What matters is the namespace name. So if you you have one document where this is prefixed with a B, and another document where it's prefixed with a C, it would still be the same because those elements are in the same namespace, right? That's the main point here. So how do you use them in Cloud Integration? You need to declare your namespaces and their prefixes on the Runtime Configuration tab of your integration flow. And the key takeaway here is that always do that before attempting to use them in Cloud Integration, because if you have a document with NS0 : something, you cannot use that prefix until it's declared. And also keep in mind that unlike in the declaration inside the XML document, there are no quotes here around the namespace name when you declare it on the Runtime Configuration tab. So where do you use namespaces in Cloud Integration? Declare them. The Runtime Configuration tab, as I just showed you. You can also do it inside XSLT style sheets. Those we'll get to. The prefixes, those you can use everywhere. You can use an XPATH expression. And I've included a link here to the standard to read on long, cold winter nights. Okay, moving on. We've lost a bit of time, so I'll increase the speed a little bit. XPATH. So XML, really great for transmitting data between systems. And now you've received an XML document and you want to extract some data from it. So how do you navigate that document? You can always write a program to parse it in Java or C#, etc. Most languages are capable of parsing XML, but that's a lot of effort, and it's also a lot of boilerplate code that we really don't like. So the better question is, how do we navigate and address the nodes inside the XML document in a more compact and succinct way? And XML path language, or XPATH, is the answer to that question. So let's take a look at what XPATH looks like. This is the most basic XPATH expression. It's called a path expression. It kind of looks like a file system path in an operating system, and it also more or less works in the same way. It guides us through the document, starting at the root element and presentation element, going to topics, and then selecting all the topic elements in that presentation document you saw earlier. And that's already pretty useful, these path expressions, but you can do a lot more in XPATH. We don't really have the time to go into more detail with all the features. That would take several separate presentations, I think. But just as a brief overview, you can navigate backwards, sideways, forwards, using the so-called XPATH axes. You can use predicates to only select certain nodes. You can aggregate information using XPATH functions, and a lot more. And you can, when you combine these features, you can very exactly pinpoint the data you need inside an XML document. And yeah, I think your key takeaway here should be that just a single XPATH expression can do the same work as dozens of lines of code. So XPATH is really expressive, it's really compact, and it packs a lot of punch. So it's absolutely worth your time to invest in learning XPATH when you're dealing with XML. Main uses in cloud integration: content modifier, a real workhorse for extracting information from an XML document. The splitters to iterate over XML content. The content filter. With that, you can do some really cool XPATH tricks as well. And then route expressions to do content-based routing, also using XPATH. A couple of links to the standard and some blog posts. That's for later. Taking us to XML schema. And XML schema is all about validation. And let's start by talking about why we would need that. And the reason is that every time you work with an XML payload, you have to make certain assumptions about it, what it looks like, right? How it's structured. When you do mapping, when you do content-based routing, based on the contents of a single element, when you extract data from the document, when you pass it in a script, and so on, you are always making assumptions about the document. And if at some point those assumptions they no longer hold, then your integration flow will very likely stop working. And it can do so sometimes immediately, just with an error failing the message, or it can also fail in more opaque ways, like a mapping can fail with an error, but if you have an XPATH expression in a router and your assumptions about the structure don't hold, then maybe you'll always just go to the default route, and that's still an error, but in your message processing log, you won't see any errors. So it might take a while until you actually discover that this doesn't work. So we want to make sure that the document has the format that we expect, and validation is the way to do that. A few more words about validity and XML schemas. The general concept of an XML schema with a lowercase s is that it's some rules and constraints that an XML document must live up to. And we say that the document is valid when it follows those rules. We talked about all XML documents having to be well-formed, but not all XML documents have to be valid, simply because not all of them have a schema, right? So well-formed always, but not necessarily valid. There are a few different schema languages. Document type definition, or DTD, was the first one. It's actually part of the XML standard. Relax NG is a competing language, XML-based. Schematron also. Schematron is a rule-based oriented schema language. And last, XML schema with a uppercase S, just to confuse us. And out of these, only XML schema is natively supported in cloud integration. So that's the one we'll be diving into here. And yeah, let me show you an example of a schema. This is the presentation document again. I simplified it a bit so it would fit on a single slide. So I reduced the presentation to 3 elements here. The schema's root element is called schema. It's in this schema namespace. We define a single element here called presentation, the root element, and then define what is the type of this element. It's a sequence of 3 other elements. Title, which is a string, presenter, another string, and then this questions accepted element, which is optional. So it has this min occurs attribute set to 0, and is defined as another complex type, but with no content. So this is an empty element. So this is a full entire working XML schema. What else can you do in schema? You can define names of elements, of course, parent-child relationships of those elements. When you do that, you build up the structure of the document, the hierarchy of the document. Attribute names and types, cardinality of elements, so how many times they can occur and how many times they must occur, and so on. Data types of the content and attributes, stuff like enumerations that restrict your content to a specific set of values. Also restrictions on the symbol types, so you can have a string that must be 10 characters long, or it must have a specific pattern that makes it look like a phone number, for instance, like a regular expression. And you can create your own types as well. You can reuse in your schemas. Also, up until XML schema 1.1, schemas were about defining the structure, basically, and the data types. You couldn't really express more complex restrictions that depend on different values from different places in your document. An example business rule could be in that purchase order example. Let's say if you're ordering products of a particular category, like hazardous goods, you need to provide some additional information. So we have a business rule that says if a category is this, then these additional elements must be present. That you couldn't really express. You could do that in Schematron, one of the alternative languages. But in XML Schema 1.1, which is the current version, and supported in Cloud Integration, you can also do this using a new element called XSLT that basically takes XPATH expressions that must evaluate to true. So this is another place where you can use XPATH. And for instance, in the presentation XML document I use, we could define a rule that says the start time of the presentation must be before the end time. That's a sort of a sensible rule to add, and we can express that using XSLT. So how do you write a schema? We don't really have any tooling in Cloud Integration for constructing schemas. Keep in mind that maybe you don't have to, because always check if there's an industry standard schema available, or maybe your communication partner has one that you can use, right? But if you do have to write one, schemas are XML documents, as you saw, and at the end of the day, it's text, so you can use any text editor, but likely so some sort of XML IDE that supports schema will make it a lot easier to build them. So unfortunately, it's an additional tool to learn and maybe pay for even. And you might be asking, can I just use a tool to generate my schema? Paraphrasing Simpsons here, yes and no. There are IDEs and tools that can generate a schema based on a sample document. And if your document is not very complicated, this can work. But obviously, this tool only knows what's in the sample document. And let's assume that the sample document represents a class of documents. So how do they differ? So you need to ask yourself, are there optional elements in there, attributes that are not in the sample document? And if that's the case, then they won't be in the schema either. And then when you receive such a document with one of those optional elements present, that will be invalid according to this schema, right? Because it doesn't know about them. Also, are there limits on repeating elements? If you have a sample document with an element that occurs 3 times, does that mean it should always occur 3 times, or at least 3 times, or between 2 and 10, and so on? That's something to keep in mind. Are the data types correct that the tool infers? And so on. And also keep in mind that it's not possible to generate the schema for any given sample document. There are infinitely many schemas that this document is valid according to, so you can't generate the schema. So use those tools as a starting point when it makes sense, but just keep those limitations in mind that I just mentioned. And I think most importantly, teach yourself enough XML schema that you understand what the tool generates for you. Don't add anything into your solution that you don't understand. That is something that will bite you in the behind later on. Yeah, that last bullet is a general point, really. I should call that Vitog's first law. Main uses of schema in cloud integration, the XML validator is absolutely the main one. Also, message mapping for the structure, and the CSV to XML converter also for the structure. Couple more links for you for the standards and a blog post, which brings us to the last standard, XSLT. And XSLT, or Extensible Stylesheet Language Transformations, that's a bit of a mouthful, is all about transforming XML into other formats. And this, message translating, that pattern is one of the most fundamental ones when you do enterprise integration, maybe the most fundamental. And yeah, in cloud integration, you have three ways to implement it. One is message mapping, the built-in visual drag and drop style mapping tool. You can implement it in scripting, where you code your transformation in JavaScript or Groovy, or XSLT. XSLT can turn one XML document into another XML document, or into other formats like plain text or HTML or JSON. Those mappings called style sheets are also XML documents. So like schema, XSLT is also an XML-based language. I'll show you a simple example. We want to turn the presentation XML from this into this. And the difference, there are two differences here. One is that the end time is gone, and we've now added a duration in minutes. And also that the topics element has been flattened. So it doesn't have any child topic elements any longer. It's just a piece of text with the topics in there. And this is the style sheet that does that. Let me go through it briefly. The main concept here is the one of the template. We've got two templates in here. This one matches the end time element in the input, and you can sort of think of these templates as consuming that element and then producing something else that will go into the output. So in this case, the end time element is consumed, and we add this duration element instead. And here we do some XSLT and XPATH magic to calculate that duration in minutes. XSL value of is a real workhorse here for computing values and then inserting them into the output. For this other template here, we are matching the topics element, and in this case, we are not consuming it, but actually copying it into the output without its child elements. And then for its content, we are using value of again to compute this string of topics with a comma between them. So flattening those child elements into a single string. Everything else in this case goes directly to the output because of this on no match attribute here. that basically says anything that's not matched by a template will go directly to the output. As you can probably see, if this is the first time you see XSLT, it's a bit different. It's based on a declarative programming paradigm, which can take a bit of getting used to. The imperative programming paradigm is much more familiar. It focuses on how to achieve something by pretty much spelling out the instructions step by step how to do something. Declarative programming instead focuses on the what. SQL is a well-known declarative language, and in SQL you are not really concerned with I/O of opening a file on the disk to read the contents of a table and then iterate through the rows and pick out the rows that fit your where criteria and so on. Instead, you just describe what you want, which columns from which table, and the criteria that it has to live up to, and then the database takes care of all the hard stuff, right? And in XSLT, this translates to defining those templates you saw, and then letting the processor do all of the heavy lifting. The processor is the engine that applies the style sheet to some XML input and creates some output. The one in Cloud Integration is called Saxon. It's a third-party product licensed by SAP, developed by a real XML veteran, some of you might know, called Michael Kay. And importantly, Saxon supports XSLT 3.0, the latest version of the standard, so that's what you have available in Cloud Integration. How do you write style sheets? How do you develop them? Like schemas, it's at the end of the day, it's just a text file. So you can write it in any text editor, even Notepad if you really have to. Also, Cloud Integration has an editor for XSLT, but in reality, it is very limited. It's a text field with some syntax highlighting, basically. So if you want to do serious XSLT development, I think neither of those options really work. So for that, you need a full IDE like XML Spy, like Oxygen, and sadly, those cost money, and it's yet another tool you need to learn. On the plus side, it can be quite good fun, I think, with the right tool to do XSLT development. Main uses, right, that's the XSLT mapping step, right? Few more links with to the standard and a couple of blog posts that you might find interesting. And with that, and a few delays, really sorry again about that. We come to the end of the presentation, got through all 4 standards and an introduction to XML itself. If you have any questions, I am happy to answer them. Also, I've got my links for the community and LinkedIn and so on in here in the presentation. It will be available afterwards. So feel free to find me there as well. Thank you.
Thank you very much, Morten, for sharing all of these details regarding the different XML standards and XML technologies that are out there. There have been a few questions in the chat, but in a way, between everyone that's in the chat, we've been able to sort of answer them. There is one that in particular that I like, it would be good to see your opinion about it. So, for example, and it's a question by Jay Erickson, which says, when is it better to use XSLT versus scripting? So yeah, what's your opinion on it? When is it better to use XSLT versus scripting in SAP Cloud Integration, for example?
That is a very good question. one of those links I had up for the XSLT section is to a blog post that compares the three mapping options basically. And I think that blog post is a long answer. The shorter one is that the real strength of XSLT in my mind is that you can, especially if you have a source and a target XML structure that are very different. One might be very deep, the other might be very wide. XSLT really excels at getting at those low, deep structures and transforming them into a very different XML structure. So something that let's say in message mapping could be ridiculously complicated can be fairly straightforward in XSLT. So that's a case where XSLT is really strong. I don't think there are cases at all where you can do something in XSLT that you couldn't do in scripting and vice versa, because you would also be able to implement this using code. So a part of it is also your preference and what do you know already, right? Because if you are a programmer or if you are a developer, it will definitely be easier to approach this using doing it in Groovy or JavaScript. So yeah, preference is definitely part of it. I most of the time lean towards XSLT, but I will also acknowledge that it has quite a steep learning curve. So it can take a while to get to the point where you can be really productive with it. The same goes for scripting to some extent, but if you want to learn XML processing in Groovy, for instance, you can. That's a smaller topic to focus on. So yeah, I don't think there's a hard and fast answer, but I would also point you to that blog post. It's in the links. But discuss it at more length. But great question.
Great.
Thank you.
Yeah, great. The slides will be shared. I shared the link to where all the slides are. The slides for these sessions are not there yet, but there will be. If you watch the recording of this, they will be there eventually. I guess for me, scripting will only make sense for XSLT. Obviously, if your input is an XML document, XSLT might be the easiest way to process it, right? But then if it's not XML, then obviously scripting might be easier. For example, if you start with a CSV file, like you might not be able to use something like XSLT there. So in that case, yeah, I guess if XML is your starting point, maybe XSLT might be the easiest path. But it is in the end something that does have a steep learning curve, as you mentioned. I completely agree with that. You mentioned about steep learning curve, right? So are there any online resources or any resources that you would recommend for someone that might be attending this session and are not that familiar with all the different standards that he shared, so that they can get started on learning about these XML standards, for example?
Yeah, that's a good point, Antonio. I mean, you shouldn't use the standards to learn, because it's more like reference, right? Because it's
Yeah.
the namespaces one is short, but the other ones are not, and it's obviously very, very detailed. So you shouldn't use those to learn about this. Lots of tutorials and pages around the web. I like the O'Reilly XSLT book. It's not completely. I think it's covers XSLT2, the previous version, but that's really good. And that will take you from complete beginner to very deep knowledge of XSLT. So if you prefer book form, long form learning, then that book is really good. It's simply called XSLT, and it's on the O'Reilly publishing house. Really good book. Use that often.
Excellent. I guess what I remember when I started learning about XSLT and XPATH and all that XQuery. My go-to resource was W3 Schools. So there's lots of tutorials there as well regarding XML and XSLT and all that. And and they even have like a playground, right, where you can write your own XSLT and then it will process it. So at least back then, I remember using that very much as well.
Yeah, that's a good resource. And if you Google XPath, XML questions, schema, XSLT, very often W3 Schools will be the top search result anyway. And yeah, that's a good resource. And maybe I didn't mention this in the presentation, but it'll take some time to learn all this stuff, right? And maybe if you've only got time to learn one, I would say go for XPath, because it's fairly easy to learn, and it will really pay off in a lot of the work you'll be doing in cloud integration, because XPath is so powerful, is so expressive that you can really it's a real superpower to have to extract data out of XML, and then when you learn the other standards like schema and XSLT, you can reuse all your XPath knowledge. XPath is a completely central element to XSLT, so that combined power of XSLT and XPath is really awesome. So yeah, if you only got time to learn one, I think make it XPath and then take it from there.
Sure. And there's one additional question here that just came from Romain. It says, let's see, how does it compare to JSON? Most REST APIs are JSON-based. Is it worth it to convert it to XML for schema validation? I guess what he means is that if you end up getting a JSON payload, is it worth converting it to XML to do schema validation there?
I mean, if what you want to achieve is to validate the content, then you don't have built-in support for something like JSON schema. But I think I would maybe go for a Java library or something and do it in a very simple script, so that you're not converting back to etc. So if validation is what you want to achieve, I think you can find a library that implements JSON schema and then do it that way. But at this point, we don't have any built-in support for. Might come in the future, right? But for the validators at this point, we've only got schema.
Yeah, that's right. Well, I think those are all the questions. So thank you very much again, Morten, for sharing your knowledge and expertise in this session.
My pleasure.
Yeah.
Thanks for having me.
Yeah, I also want to thank the viewer for joining the live event. There were lots of questions. It was quite a lively chat, and also lots of concurrent views as well. Or even if you're watching the recording of this session as well. And I just want to remind everyone that there is plenty for everyone to learn during the DevFest. So make sure to check out all the sessions that are part of the event. And that's it. Thank you very much.
Thanks a lot, everybody.
Excellent. So